All right, in this lesson right here, what we're going to be doing is taking a look at arrays. And arrays are going to become something very, very important that you're going to need to understand for your programming career. They really rank up there as one of the most used things.
Definitely.
And you guys will really see why when we start getting into talking about pointers, et cetera, et cetera. But you're going to find us using arrays quite often. Now, what are arrays? Well, they're just variables.
Yes, they are.
But they're kind of special variables in a sense. And what I'd like to do before I give control back over to our teacher here, Mr. Joel. That's right, I forgot I'm the student. I'd like to go ahead and give, instead of some coding examples, perhaps bring up Notepad, and let's give some examples inside of Notepad. So far we've seen some very simple stuff like how to create very simple variables, integers and floats and
doubles.
And doubles, yeah. So, you went in there and did something like int I, like that, right?
Right.
And this just made a variable that we could put some information in. And we've seen that this is basically 4 bytes that have been reserved in memory that we can store whole numbers in. So what I want to do is I'm going to represent that memory location with something like that. It's kind of like just a box. And in that box right there, picture your 4 bytes. And we could store something like, well, right now, with this code right here, Joel, what do we have down here?
Well, we have something.
Something. Who knows? It could be anything. But if I was to come in here and do a declaration and an initialization at the same time, now what do we have down here?
0.
So we have a 0 in there. It's just what I'm trying to do is, since we don't really have a board to draw this out on, I'm just trying to kind of use Notepad to give a visual representation.
Buzz needs his whiteboard.
That's right. I need it bad right about now. So the whole key here is just being able to understand that it's a container, basically, that's got some sort of information in it. Now, I don't want to get into how it's going to be set up yet in regards to the syntax and the code for defining or declaring variables, but I want to talk about what they are and show you what they look like in comparison to this representation of an integer variable. So first of all, an array is nothing more than a variable that is really a collection of that variable type.
Right.
Meaning that, well, here's a way to put it. Let's use the old post office mailbox analogy. And we'll use that hand in hand while talking with what a variable is, or a variable array. So first of all, an array being a collection of a particular type of variable. So if I had an integer array, then it would have an array that would hold yay so many integers.
Right.
Okay. But it would be a single variable. Now we all have, or at least most of us have anyways, a mailbox out front. And a mailbox is a container, and it has been designed to hold something. In our case, it's to hold mail. But it's holding data, right?
Right.
In which we're going to go and retrieve later on, or put stuff in it for the postman to pick up. So it acts in the real world just like a variable does in the computer. Now, if we were going to start talking about an array in this sense, we'd have to say that a post office would be an actual variable array. Because the post office, I can say, Joel, I want you to go to the post office here in town. But when he gets to the post office is broken down even further internally with a whole bunch of compartments. These are your P.O. boxes that are all set up to hold mail.
Right.
So now you're storing a particular data type, that would be mail, and you've got a whole bunch of compartments to hold them. So as opposed to your single mailbox out front, which was set up to hold one type of thing, okay, but, I mean, we only have that one compartment. At the post office, we've got a bunch of compartments all inside the post office. Now, if you were able to go and magically rip the post office out of the ground, right, and transport it to another location, you would be taking all of those P.O. boxes inside with it. Okay, so that way, if you were able to really transport a post office box around like that, it'd be kind of handy because you're moving all of these different containers all at one time by moving just one container. So that's basically what we're dealing with variables. So if I was to set up an array of integers, let's say the array had 3 elements inside of it. Basically what we'd end up with would be something, let me do this, something that looked like this. I'm kind of reaching across Joel at the moment to type on the keyboard, so no funny stuff, Joel. Okay, so what do we have here? We've got 3 compartments.
Yes,
1,
we do.
2, 3. But if this thing was established as, let's say it was called post office. There we go.
Right.
And we can actually use that in a few minutes when we jump over into code. And we said that the post office has 3 compartments in it.
Right.
Right? That's what we've got, 3
Right.
compartments. And then we can go in there and we can start referring to, and it's 0-based. So I could say post office sub 0 has whatever in it, and I
Right.
could put that whatever into it, or sub 1, or sub 2, okay? So just keep the whole 0-base thing in mind. But the idea is this. Up here, when I set this guy up, I mean, I could go ahead and come down here and just
Right,
do
just
like
to
that.
finish it off.
And we can go ahead and come over here and just do one of those little guys right there. You feeling pretty good, Joel?
Yes, I am.
All right. So up here we have, I said I wasn't going to get into syntax, but kind of starting to bleed over into that. But up here what I've done is I've said, look, give me some memory, give me 4 bytes of memory that's going to hold an integer, and go ahead and initialize it with a 0 in it. And that's what we've done down here. And we've got our one little box right there. Now here I've said, give me an array, but it's still a variable.
Right.
But give me an
Still
array.
one name.
It's still one name, but I want that array or that variable to have 3 elements or 3 components, okay? Or it could have been 4. I mean, if this would have been 4, basically what we would have gotten back would have been
Just
this right here.
Right,
Would have
one
had-
more space to put stuff
You
in.
got it. And so then we can come in here and we can start putting information. And so if we wanted to, 4 in that one, we could have stored a 1 over here. And let's say we initialize these 2 guys to 0. So we're just storing information in there. And to put information in there, I mean, it's really simple. It's just a matter of coming down. And if we were to, well, let's do this. Let's jump up here. If we would have said something like post office sub 0, 1, let's say 1 equals 1, then this is what we would have had down here in regards to this first element having
Right.
a 1 in it. Now, this right now, this could have been, who knows what, the 4, number 4, that could have just randomly been there since
Exactly.
we haven't actually specified anything yet for 4. And we'd have been also lucky if these would have actually been 0, but, you know, again, some sort of random information. But we have explicitly put a 1 into that slot right now. Keep in mind, let me go ahead and do this. This might make it easier to see. Here's our index map, if you will, 0, 1, 2, 3.
So always keep in mind it's 0 base.
That's right. So up here, where we say 1, we're talking to this slot right here. So if this would have been, let's say, 3, and I would have done something like this and rerun this, then what we would have had would have been this over here, and who knows what would have ended up in here. I mean,
right,
it
in
could
the
have...
first 3 elements, we have no idea what's in them.
Yeah, it could have been 2. Could have been anything. Who knows?
Right.
Unless we would have specified them ourselves. So this becomes really important when you start dealing with a bunch of data that you need to have kind of grouped together
Right.
and treat it like a single variable. And again, this is something that you're going to see us do a lot. So this is just a real simple breakdown right here, just trying to show you the difference between an array and a regular variable. So I guess I could say a variable array.
Right.
And just understanding it's rather a single component with a regular variable, or if we're dealing with an array, then what we've got is it's a single variable, post office in this particular case, but it contains multiple elements depending upon how many elements you told it to have when you actually declared it.
Right.
Okay. So with this, what I'd like to do is hand this over to Joel, since he's sitting in front of the keyboard and mouse, and let him go ahead, and he's also the instructor.
Right.
Go ahead and
Well,
let
I
him.
try to be.
I know. I'm sorry, but here we go. Let's see. We'll grab that guy right there, and I'll slide the keyboard over. There you go.
All right.
Nice working with you, Joel. And thank you very much for allowing me to go to the white board, notepad, and do that.
No problem.
So keep that stuff in mind, and let Joel show you a couple
Right, so pretty much,
big
I mean,
things.
you've already said
Do it again.
everything, but let's kind of just give a few examples to clarify things.
Absolutely.
So let's declare our integer post office. So we have our integer post office, and we'll give it, say, 10 elements.
All right, sounds good.
So our array post office is going to hold 10 elements. So right like that, our array is completely uninitialized. We have no idea what's in there.
Let's put a breakpoint in there.
And just go inside of the code to see what's in there.
Yeah.
So yes, we want to go inside. So it's already run that line of code, and if we go up here and type post, spell it right, post office, this is where our array is, right, this area right here.
Okay.
And it's kind of hard to see because it's not initialized.
Now, is there something different in the way you typed post office up there, and earlier you were typing other variable names?
This is an important thing because post office is already holding the address, so we don't need to type the ampersand like we did before.
I just wanted to point that out for those of you right now that just cocked one eyebrow at an angle and went,
Why did you do that?
Don't worry. The pointers is something we're going to be getting into soon.
Right.
It's actually in the next module. But we're not wanting you guys to
overstress about that.
Right. I just wanted to say, just in case somebody out there is watching this and they say, wait a minute, earlier he
put an
had
ampersand.
that in there. What's
Right.
going on? Don't worry. We know what we're doing. We just want to point out that there's a little subtle difference going on.
Right.
There.
Have a little faith.
That's right.
So let's go in here and actually initialize these things. Oh, actually, before we do that, let's go down to our locals down here. And if we expand this, you'll notice we have 0.
Check it out. They drew it just like I did over in Notepad.
Yes, they did.
I drew it across. They drew it down. Why? Because they just didn't have as much room as I did.
Oh, yeah. Their whiteboards suck.
That's right.
So if we look down here, we have exactly up till 9, which is 10 elements.
That's right.
Which is very, very cool.
And what's in there
is kind of random values. Garbage.
Right.
So let's stop debugging and let's initialize this. One way we can initialize it is just going to here, instead of typing 0, if we did that, if we press Control F7, we get an error.
Ow.
That won't work.
Mommy.
So what we can do is just put this in curly braces, and if we press Control F7, everything is fine. And what that's just done is initialized all of the elements in our post office to 0.
It's kind of special.
Yes, it is. What we could do is, just to show off this curly braces thing, if we change this to just 3 elements, we can initialize all 3 of those in the initialization right here by separating each of the elements with commas.
That's right.
So we can say comma 1, 2, 0, 1, and 2, and that means the first element's going to be 0, second element 1, and third element
Let's show them. Let's jump into memory and show them those bytes right there.
So we press F5, and let's press
We've got
F10
12
to go
bytes that have been given to us.
Right, and let's just type in post office up here. And you'll notice the first one is going to be 0.
Remember, it counts from left over to right.
Right. And the first one is 1 if you look over here. And the last one is 2.
Just like and just to show them that this is no smoke and mirrors, magical tricks here.
Right.
Change the numbers to something like how about 543?
Right. And just quickly down here, we can also look at our locals, and it does say there's 0, 1, and 2. That is kind of confusing though, so we might as well stop debugging and change this over to random values. 5, 4, 3. Good enough.
Boy, that's random.
Yes, it is. So if we press F5 and go into here, you'll notice we press F10 to run that line, and look,
5, 4,
down
3.
here, 5, 4, 3. If you look at the top, 5, 4, and 3.
3, as long as Joel's not highlighting all of the memory. No, I'm just kidding.
As long as I try not to.
I know.
So let's stop debugging, and let's kind of expand this just a little bit. Oh, and actually we need to show this yet. We can go into here and change this to 0, and that initializes all of the elements to 0. So if we go ahead and run this.
And as we've already preached, it's a really good idea to always make sure you initialize your variables, boom, right off the bat.
So we could just press F10, and you notice everything is set to 0.
All 0. Smart move.
All is good. All right, so with that, let's go ahead and kind of experiment with doing some more things. Let's go down here, and as Buzz showed in Notepad, or his whiteboard, we can go into here and say post office, and specify the element we want to change. Let's say 0, and we can initialize
22.
It to 0. Okay, 22. Something more interesting.
Yeah.
So that's actually initializing, and let's just run that. It's kind of good to see what's going on. So we initialize all of them to 0 down here, and this line is going to initialize, or assign, the first element to 22. So look down here in the first line, dink, now it's 22. So very cool.
And of course, take a look at it in memory.
Take a look at it in memory.
Yeah, what do you have?
We have 16.
Why do we have 16? It's not a bad thing because we're dealing with hex. That's right, meaning that it's base 16. So the first number right here represents, the first number on this side, if you will, represents our, we can count from 0 all the way up to 15. Right. Which is actually 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And then as soon as we hit 0 there, and 1 falls over here, this is our 16s category. So we've got 116, add 6 to that.
And you get 22.
You get 22. To prove this, how about this? How about let's put something like, how about 10?
All right.
Oh, wait a minute, 16, because that'll give us 10 up there.
All right, so we can change it down here to 10. And you want to change it to 15. My bad.
That would give us an F.
Exactly, that would give us an F.
I was looking for 16, so they see a 10 up there in the memory location.
Okay. So we changed this to 16.
We can play this game all day long. We see a 1-0 up there.
Yes, finally, we see our 1-0.
I'm frightened.
I'm scared. Okay. Both instructors scared is kind of a bad thing.
Might as well stop recording right now.
Yeah, right. So, right here we've got all that set up.
Okay.
Let's go ahead and stop our debugging.
Sorry for the quick hex lesson, but I just thought you might.
Yeah, it is kind of important.
I'd like to know why we're pointing to a memory location that looks like it's containing a completely different number.
Right, 22, 16. Why?
Exactly. There is a relationship, we promise.
Definitely. So let's also go in here and change. Let's just change another element to show that we can do this. So let's change all of these to say something like that. Copy, paste, paste. So now we're going to initialize all of the elements. Actually, one more than we have.
Yeah.
So let's change that to 4, because
Okay.
I want 4 elements. And let's say 32, 87.
Well, what happens if you go past that?
That's actually an interesting thing. Let me get rid and change this to 3.
Okay.
Just show you. It's kind of a bad thing.
Yeah.
You know, let's press Control F7, which will compile it. And you'll notice no errors.
Right.
This is a very important thing because we don't have this. We don't have this element.
We've
Why can
not
we access
asked for that.
We haven't asked for it.
That's right.
Yeah, why can we access it? That's kind of a scary thing, isn't it?
Yes, it is.
So if we press F5, yes, we want to build. We initialize all of them to 0. You notice we have 3 elements, not 4. We initialize the first to 22, second to 52, third to 87. Now, if we go up to here and type post office, just to make sure it's in the right area, yes, it is. We have 16, which is 22, 34, which is 52, and 57, which is 87. This last memory address has nothing in it.
Right.
If we press F10, it initialized it. We weren't supposed to be able to initialize it.
Right.
Because that's kind of a dangerous thing that we're doing here.
It's a very dangerous thing, actually.
Right, and it can result in such things as memory leaks.
Exactly.
Which is a bad thing. But we'll definitely be talking about this a lot more when we get to pointers and dynamic memory.
Right. I wasn't meant to branch off into a whole lecture about it, but it was to show that you need to make sure, at least at this point in time, what you specify is what you use. Don't go in there and say, I'm going to assign 3, but I'm going to use 15 elements.
Exactly.
Because you don't know whose memory you're writing
Right.
over.
That's a bad thing.
Yes, it is. You ever heard of crashing before?
Exactly. So let's stop debugging. And let's go into here and kind of comment
Fix
that out.
our problem.
And let's delete this. And let's actually, continuing with the whole post office mailbox thing,
Okay.
let's declare another variable called mailbox.
I like it.
And we'll assign this to, say, 3. Or actually 2. Okay?
Okay.
So basically we're saying we want to access the second mailbox.
Okay.
Which would be our second element.
And this really goes to show that, when we go in there and specify which index, just remember this is referring to an index right here.
Right.
When we're referring to an index, we don't have to hard code a number in there.
No, definitely not.
Generally, you don't.
No, you don't.
Okay.
Because, when you're starting to write your own code, you don't really know which element you really want to access.
Exactly.
So we can change this to mailbox, and that's going to access the second element, well, actually the third,
Right,
since
0,
it's
1,
0-based.
2.
And it's going to put 22 in there. So if we go in here, put our breakpoint down, press F5, guess we want to build, and you'll notice it sets them all to 0, sets mailbox equal to 2, and then assigns the last element to 22.
Very nice.
So all is good. So let's stop debugging yet again. And let's go in here and show just one more example just to kind of clarify things just a little bit more. And we'll do a whole loop. So we can say int, and we'll change this to mailbox. So why don't we just get rid of this? We don't need him, and we don't need him.
And the idea of showing this mailbox inside the force, just so you guys know that for those of you that are still kind of new to the whole programming thing, and you saw in the last lesson when we did for loops, or, when we did the for loops lesson.
Right.
You
weren't quite sure why.
We're using an I. We don't have to always use I. It could be whatever
anything we
want. That's right.
Or you can use an existing variable. You don't have to always declare a new variable here.
That's a fact.
So we can say integer mailbox equals 0, so we assign it to 0 at first, and then we can say mailbox is less than the number of elements we have, which is 3.
Okay.
Or actually, in this case, we do want to do 3. So let's say this, and we can say mailbox.
Because it means we'll never hit 3. Once we hit 3, we're jumping out of the loop.
Exactly, since it's 0-based.
Right.
So we plus plus, and let's just put the curly braces to make it a little bit clearer for you guys to see it, understand it. And let's set post office, and the element that we want to change is mailbox, and we'll equate that to, what do you want to equate it to?
How about let's just start out by putting whatever mailbox contains at the moment, so that as mailbox goes 0, 1, 2,
okay,
it'll
so
put 0, 1, 2 in the first slot, second slot, then the third slot.
Right. So let's go into here and press F5. Yes, we want to build. Let's just walk through this. Set all the elements to 0. Mailbox hasn't been declared yet, so it's a weird value. And we go through it. It sets mailbox, the first element, to 0, so we won't see any change. Goes through the next one, sets the second element to 1, as you can see down here.
There.
Goes through again, mailbox is now
changing.
2.
That's right.
And we run it again, and the last element is equal to 2.
Isn't that kind of cool?
It is kind of cool. So what we can do is stop debugging, and we can put any values in here that we want, obviously.
Randomize some stuff.
Yeah, we can even pump a random into.
Ooh, that looks scary. I've never seen that before. Joel, what's going on? Huh? Tell me.
I don't know. Hi. And what we can, this is basically just calling the rand function, which is going to, that's why we have these two parentheses here, which says that it's a function.
Okay.
And this rand function is going to return to us a random value.
How does it know where the rand function is?
Well, it just knows. Let's just think of that. It's because we're including IOStream over here.
There you go.
So, actually, I'm getting myself a little confused here. It directly has that in there, so that's kind of...
Okay, so it's built in.
Right.
Okay.
So what we can do is kind of go into here. Yes, we want to build. And go into here, and it sets them all to 0. We go through, and as you can see, we get a random value of 41.
A funky value.
And one last funky value.
And a funky value.
Very cool. So, as you can see, that's basically arrays in a nutshell, and we can even go in here and change this completely around to say, I want double. I want my arrays to be doubles.
Yeah, so we have a more accurate number.
Right. So we can go into here and say, you know what, just to clarify things a little bit, we can go in here and say mailbox. My bad. We can change this to 0.2, something like 0.2, and we can multiply that by mailbox. So we're going to get a floating value, which is kind of cool. So we can go in here, press F10. Yes, we want to do that. Press F10, so mailbox.
Could have multiplied it by 1.2 to...
make it even more random.
Well, no, just so that you could see...
True.
Easier for those that aren't mathematically inclined. Not me! Oh, sorry.
So we can say 0. Of course, the first element's going to be 0.
I didn't do that one.
We go to it again, and now the second element's going to be 0.2.
Right.
Do you know what the last element's going to be?
I have no clue.
0.4. So we get 0.4.
Of course. 2 times 2 is 4. Move the decimal over once. Woohoo!
You're so smart.
Anything past 2 plus 2 is over my head. You know that.
Oh, true.
Oh, whatever it takes to keep us awake, right?
So let's press F9 to get rid of that. And you know, we can put any value in here, but it is a good thing to keep in mind that our index cannot be like, say, a double or a floating value.
Right,
It has to be a solid whole number.
Exactly.
So with that really wraps it up. I mean, we covered everything that you need to actually learn how to use arrays.
And don't be shy, because I'll tell you what, we're coming back around where we're going to be using arrays a lot from this point forward, and we're just going to assume that you guys are experts and know everything about C++, so we can just start coding away now.
Exactly.
Just kidding. All right, so that's going to wrap up this lesson. Hope you guys got a lot out of it. Thanks a lot.